Today's lesson is about finding sides in right-angled triangle using trigonometry. Let's recall the sides of the triangle. It tells us that the working angle is the upper angle. So let's name it angle A. We have three sides of a right-angled triangle when we have an angle to deal with. So first of all, the easiest one for us to identify is the side across from the 90-degree angle. This is our hypotenuse. So by definition, hypotenuse is the side across from the 90 degrees. One of the properties of the hypotenuse is that it is always the longest side. Now, it's not a definition of a hypotenuse, but it's a property. Now, our other two sides will depend on where our working angle is. In this case, our working angle is the upper corner, and so the opposite is going to be this side that is opposite to the working angle. And we have our adjacent. This is the side that's in between our working angle and the 90 degrees. Now, if our working angle was not here and our working angle was down here, so let's talk about angle B. If we're talking about angle B, then the side across from angle B would be here, and this would be called our opposite. And this side is the adjacent for angle B. So always the side names are relative to where the working angle is. Let's talk about measurements. In grade 10 and 11 math, we use degrees. There are radians and gradients, but you won't see that until later on. So it's like measuring temperature. In Canada, we measure temperature using Celsius. In America, they use Fahrenheit. Nothing wrong with either systems, it's just different. And so we want to make sure that we are using degrees, so we're referring to the same units. If you are using the Desmos scientific calculator, you need to make sure that you have this little tab switched to degrees. If you're on a phone calculator, you need to see RAD. It's not super intuitive, but when you see RAD, then you know it's in degrees, because if you hit RAD, it'll turn into DEG, but then it'll show up here that you're using radians. If you're using one of the school calculators or you have a handheld calculator at home, you need to familiarize yourself with this button, DRG. That's for changing it from degrees to radians to gradients. And somewhere up on the screen, it'll indicate that you're in degrees. And often it says DEG, or it's a little box with a D in it. Now, for us to make sure you are in degrees, I'm going to calculate these three, and I want you to try it on your calculator to see whether it's possible for you to get the same answers. So in the Desmos scientific calculator, we would type in sine 60. And since I know I'm in degrees, I get the decimal value of 0.866. For sine 30, I have zero point 0.5. And if you're using a Desmo Scientific Calculator, you can click on this button to convert it into a decimal or into a fraction. Finally, sine 90, you should get 1. Okay, so we're going to use trigonometry to help us find a side length. Now let's recall. Yesterday, I talked about our memory trick. We could talk about so, ka, toa, and this is the memory trick that we use to remember our primary trig ratios. S for sine, C for cosine, and T for tan. Now, what we need to do is we're going to set up one of these ratios and solve for the x. Let's identify the sides that we're given. So we have working angle here, that's a 30, and we have a 90 degrees, so we know that this is a right angle triangle. Since it's a right angle triangle, I can use one of these primary trig ratios. Now, hypotenuse would be our 29, because we see that this is across from the 90 degrees. And the letter x is our adjacent. We know that it's the adjacent because it's in between the 90 degrees and our working angle. Now that we have identified the two sides, we don't really need to involve this side, the opposite, because we know that for all of our ratios, we only need to have two sides. So we check our menu here, which trig ratio involves the adjacent and the hypotenuse. We would have to use cosine because cosine is the only one that has a ratio that requires the adjacent and the hypotenuse. So let's write out our ratio. Cosine A is equal to adjacent over hypotenuse. So this is the general ratio. Let me fill it in with the um, let's fill it in with the information we have. So cosine 30 is equal to x over 29. Just a side note here, I want you to remember that if I have cosine 39, it's going to turn out to be a number. But we know that we can divide any number by 1 and it makes it a fraction. So cosine 30 is equal to x over 39, or 29, is equivalent to me writing it like this. We're going to cross multiply next. And when I cross multiply, I'm going to take these two, and that will equal these two. So let's cross multiply. I have 29 cosine 30. Now it's conventional for us to put the whole number in front and then have cosine 30, and this is equal to x. Let's continue on to solve. So we have 29 times cosine 30, and it gives us x as 25.11. Let's do another example. So remember the first thing, we need to identify the sides that are involved. So I have my working angle here. Across from it, we have our opposite. Okay, this is the x, and this is across from the 90 degrees. So this is our hypotenuse. Let's check our menu for trig ratios again. SOHCAHTOA. And we see that the only trig ratio that involves the opposite and the hypotenuse would be our sine ratio. So we've decided we're going to use sine A is equal to opposite over hypotenuse. Let's substitute our values in. So I have sine 56 is equal to 9.1 over x. Once we've set up with the ratio, we're going to solve the ratio using cross multiplication. So once again, as a reminder, sine 56, we can rewrite this as sine 56 over 1, and that's equal to 9.1 over x. Now, we need to cross multiply, so we're going to take these two, and that's equal to these two. Now, we have x sine 56 is equal to 9.1 times 1. And since it's times by 1, I don't have to write that because I know that it's equal to itself. Okay, we need to continue on with algebra because the x is not on its own. But I know if I divided both sides by sine 56, I can get x on its own. On the left side, the two sine 56's divide out, and we just have x is equal to 9.1 over sine 56. Now, this is called the exact answer. I call this the exact answer because there's no rounding involved. It's the most precise because I haven't rounded anything. Now, usually with trigonometry, once you use sine, cos, and tan, you're almost guaranteed to get a decimal spot. So we can get our rounded answer by taking it and putting it into the calculator. So 9.1 over sine 56. In this case, I have 10.97. That's our first two decimal spots. But if I'm going to round it, I need to actually look at the spot after where I'm rounding. If it's 5 or greater, then the number needs to go up. If it's 4 or less, then we just drop the rest. Okay, so our rounded answer, we have 10.98 centimeters. And this is our rounded answer. Let's do one more example here. Use trig to find the side length. So first of all, we need to identify the sides that are involved. We have 60 here as our working angle, and across from it, we have our opposite. In between the 90-degree and the working angle, we have the adjacent. So let's check our menu. We know that the menu has so, ka, and toa. The only trig ratio that involves both adjacent and opposite would be tangent. So we're going to use the equation tan A is equal to opposite over adjacent. Let's substitute the values in. So we have tan 60 is equal to 10.4 over x. Now we're going to cross multiply to solve. So I have x tan 60 is equal to 10.4. X is equal to 10.4 divided by tan 60. I have 10.4 divided by tan 60, and to two decimal spots, it would be 6.00. The third number is a 4. So because it's 4 or under, we're going to just drop all of that and round our answer to 6.0. Okay, one more example for good measure. We're going to use trig to solve for side x. The first thing we do, we need to identify the sides. So our working angle is 35. Across from the working angle is our opposite side. 7 centimeters, this is across from the 90 degrees. So this is our hypotenuse. Let's check our menu for trig ratios. SOHCAHTOA, only when it involves the opposite and the hypotenuse would be our sine. Let's write that down. So sine A is equal to opposite over hypotenuse. Let's substitute our values in. So sine 35 equals x over 7. Now let's cross multiply. 7 times sine 35 is equal to x. We've got our exact answer already. Now let's get our rounded answer by substituting it into the calculator to solve. So 7 sine 35, 4.015. Now 5 is the extra decimal spot, but since it's 5, we're going to round the number before up. 4.02. The next two slides, I'd like you to try this on your own. Pause the video, work on this and this one, and we'll take it up. Okay, to take up the try this on your own slides. For this triangle, we've used cosine, and our answer is 19.19. This is the calculation that I used. And for this slide, we used tan and solved. It's that. So this is the calculation that I used.